Hello, my name is Oscar Acostas. I'm a postdoc associate at the University of Maryland, College Park, and this presentation concerns the poster Investigation of Seismic and Infrasound Waves Generated by an Airburst near Qaanaaq, Greenland. On the top of the poster, you may see the location of the airburst on the western part of Greenland and a comparative figure about the conditions of occurrence of airburst in different planetary bodies with different atmospheric conditions. In this study, we use an airburst that happened on Earth, a planet with a dense atmosphere, in order to do an inversion of the local structure in the place of the event and provide a methodology that can be used in extraterrestrial experiments such as the Dragonfly mission that will carry seismometers on Titan. In the second section of the poster, some basics about the propagation of shock waves generated by meteoroids are shown. And when the meteoroid enters the atmosphere, a shock wave is generated, which converts into a linear acoustic wave in the atmosphere or generates seismic waves in the solid part of the planet. The shock wave is characterized by an overpressure which decays with the time and distance of propagation, and this distance is denoted by an radius r0. In this figure, it is shown how the shock wave ray travels from the meteoroid trajectory point to the observer. So the Qaanaaq airburst, which occurred on July 25, 2018, released an energy equivalent of 2.1 kilotons of TNT and entered with a meteoroid speed of 24.4 kilometers per second as provided by CNEOS. And it occurred in an epicenter distance of around 40 kilometers north of the Tuleg seismic station. In this study, we used the atmospheric parameters of the location in order to compute the Mach number and then compute the shockwave propagation and provide evidence about the conversion of the point of the conversion of this shockwave into a linear acoustic wave. This wave is the one that is recorded by infrasound sensors, and these are CTBTO data that show these waveforms that are characteristic of linear acoustic waves that are generated by shock waves. And we perform an analysis through computation of the ray path in order to feed these arrivals into a model. The seismic data show a very clear broadband signal which corresponds to this atmospheric wave, and this can be shown either on the spectrogram or the time series in lower frequencies, where a precursor is also shown, and further investigation is needed about this. So using this data, we perform seismic modeling, and in order to do the modeling of the source, we consider the line source in the atmosphere as the ensemble of consecutive point sources, and by using the parameters of the atmosphere, we provide a solution about relative values of the moment tensor. So through this modeling, we expect to be able to do the inversion of the local structure in Greenland, and this will eventually validate the methodology in order to be used in the extraterrestrial setting, which is the scope of the study. Thank you.